Welcome to Spring LIB.
For this problem on the topic of periodic motion, we are given a tuning fork with a labeled frequency, and we are told the amplitude at which its two prongs are vibrating. We want to calculate the maximum speed of the tip of the prong, and we want to calculate the kinetic energy, the maximum kinetic energy of a fly that's holding onto the tip of one of the prong, assuming that the fly's mass is negligible. So firstly, to calculate the maximum velocity, we know that Vmax is equal to the angular frequency omega times the amplitude of the oscillations A. And we can write this as 2 pi f, which is omega, times the amplitude A. Since we know these values, we can calculate this maximum speed. So this is 2 pi times the frequency of oscillations, which is the frequency of the tuning fork, 392 hertz, times the amplitude of oscillations, 0.6 times 10 to the minus 3 in meters. So with our values in SI units, we get the maximum speed of the tip of the prong to be 1.48 meters per second. So that's our first answer. Now that we have the maximum speed of the tip of the prong, we want to calculate the maximum kinetic energy of a fly that's holding on to one of the tips of the prongs. So the maximum kinetic energy, we'll call it Kmax, we know is a half m v squared, where v is now the maximum velocity Vmax. So if we substitute our values into this, we can get the kinetic energy, assuming that all the kinetic energy is transferred to the fly, and that's a half into the mass of the fly, 0.027 times 10 to the minus 3 kg times the speed of the oscillations, 1.48 meters per second squared, and that's Vmax. So calculating, we get the maximum kinetic energy transferred to the fly to be 2.96 times 10 to the minus 5 joules.